say that the speed of a car is 60 kilometers per hour, that tells you something. But if I say that the car is moving at 60 kilometers towards Delhi, now that tells you something more. Same number, completely different meanings. And that difference is what vectors are all about. I know what many of you might be thinking when you hear the word vectors. It's about arrows, diagrams, components, I cap, j cap, etc. And suddenly that's what makes you feel that it's complicated. But today, I promise you something that by the end of this video, vectors will feel logical and not scary. Vectors are the language of physics. For example, force, velocity, acceleration, all are vectors. Even when you walk from one room to another room, you are creating a displacement vector. Let's start with the most basic question: what is a vector? Now, if you want to understand what is a vector, so a vector is something that has magnitude and direction both. All vectors follow the triangle law of vector addition. And if you have to give you some more examples about vector quantities here, then we have velocity, acceleration, force. Now, when you talk about the vector, how are they symbol or what is their symbol? So you just write the vector AB and put an arrowhead at the top of it. So this arrowhead at the top is what is the symbol AB giving to you. And if I put it between these two lines over here, the modulus that you see, that is what is the magnitude of the vector. In olden days, we used to make use of something known as a graphical representation, also called the pictorial representation of a vector. Now, in case of a pictorial representation, we would draw an arrow in order to represent any vector. In the arrow, the length of the vector represents the magnitude, or the length of this arrow represents the magnitude of the vector. So longer the tail, greater would be the magnitude of the vector, and the head of the arrow represents the direction in which the vector is pointing. We'll talk about two most common properties of a vector. The first one being the shifting of a vector. Shifting of a vector means that I am moving the vector over the graph. Now let's say that you have a vector like this. It's pointing like this, AB. Now I can pick up this vector from here and go and keep it anywhere on this whole screen. I can go and put it here or any other point that you feel like, provided that the length of the vector, which is representing the magnitude, and the direction of this vector does not change. You can put the vector anywhere on the screen, but the length and the direction have to be kept the same. That's the most important part that you have to keep in mind while shifting the vector. Now you can also interchange the position of the head and tail. That will make the direction of your vector change by 180 degrees. So suppose now I want to shift this vector by 180 degrees, or I want to rotate my vector by 180 degrees, then I keep the length same, but I change the arrowhead to the other side. So this is AB vector. You can call this AB dash vector, which has been rotated by 180 degrees. So the direction has become completely opposite, although magnitude wise it is still the same. Further, we move on to talking about the angle of the vector. Now it is the angle made by the vector with the positive axis. What does it mean? Okay, so let's say I have my x-axis right here and I have my y-axis right here, and I can also show my third axis, which is the z-axis, pointing like this. So this is how I have kept my coordinate system. Now I can draw any vector over here. This is my origin. Let's say I draw a vector like this. This OA is representing a vector. Okay, now the angle that it is making with the x-axis is what we represent as alpha. The angle that the vector makes with the y-axis is what we represent as beta. And the angle that my vector makes with the z-axis is what is called gamma. So I have alpha, beta and gamma that are representing the angles that are made by the vector. So you can simply say alpha is the angle made with the positive x-axis, beta is the angle made with the positive y-axis, and gamma is the angle made with the positive z-axis. it like, so if I have a vector r, I can represent it as x times I cap. So x is the magnitude along the I direction. I direction means along the x axis. Then I have y j cap, and I can have z k cap. What exactly do these I, j and k mean? I cap is a unit vector along the x direction, j cap is a unit vector along the y direction, and k cap is a unit vector along the z direction. What is a unit vector? A unit vector has a magnitude of 1 and it can point in any directions. So three specific unit vectors we have taken to define the coordinate system. So I cap is representing the x direction, j cap is representing the y direction, and k cap is representing the z direction. This is same as telling you that my r has coordinates of x, y, z along the three axes x, y and z. So this is just like the coordinate system over here. Apart from this, if I have any vector, let's say as I have a vector A, I can multiply this vector by a scalar quantity. So k is a positive scalar, and if I multiply this k with my vector r, only the magnitude of this will increase. So if you multiply this k with some vector over here, let's say we are multiplying it by the vector r, then it only represents the magnitude getting multiplied some k times. So you will have k times x I cap plus k times y j cap plus k times z k cap. If k was a scalar quantity, but if it was in the negative direction, suppose if your k is a negative scalar, then the magnitude will get multiplied k times, of course, but the direction would also get reversed. Then the direction of the vector also gets. Now let us try to understand the representation or the general form of a vector. Now to represent the general form of a vector, let's say I have a vector r, and this r can be represented as x I cap, y j cap plus z k cap. Now these I cap, j cap and k cap represent unit vectors along the different directions. Unit vectors are those that only represent direction and does not give rise to any magnitude. Their magnitude by default is 1, but they are only representing direction. So if you talk about the I cap is a unit vector along the positive x direction. It's a unit vector along the positive y direction. Then you have j cap, which is a unit vector along the positive y direction. Then you have z cap, which is a unit vector along the positive z direction. As x I cap plus y j cap plus z k cap, I can actually write the angle cosines. What are these angle cosines? How much does this vector make in terms of cos with the x-axis, with the y-axis, is what we are talking about here. If you remember, alpha was the angle made by the vector with the positive x-axis. So if I want to define cos alpha will be equal to the component of this vector along the x-axis, which we know is going to be equal to x in this particular scenario, right? Divided by the magnitude of this vector. The magnitude of this vector would be given by x square plus y square plus z square for any vector which is defined as xi cap plus yj cap plus zk cap. Its magnitude, if you want to write, it would be equal to root of x square plus y square plus z square. So this is my cos alpha. Similarly, if I want to write cos beta, now for cos beta, it would be equal to the y component divided by the magnitude. So the y component of this vector r is y, and that divided by the magnitude, which is x square plus y square plus z square. I can also write the angle that is made with the y-axis, which is going to be cos gamma, and that would be equal to z divided by root of x square plus y square plus z square. So that respective component divided by the magnitude. To understand this, how we get this is actually pretty easy. So if I explain this the same thing to you in terms of just the x-axis, let's say this is my x-axis, this is my y-axis, right? So I have a vector like this, right, making an angle alpha here. If I want to write the cos alpha for this particular triangle, then cos alpha from here would be simply equal to PR by PQ. Now if you look in carefully, PR is nothing but the value x, the x component, right? And PQ is nothing but it's just the magnitude of the vector r. So that is why we are doing the respective angle component divided by the magnitude. So x by x square plus y square plus z square under the root. This is how we write the cosines. Fine, I hope you understand that. Let's move on to the next part where we will talk about the triangle law of vector addition. So let's say that there are two vectors, a vector A with a magnitude A, okay, and a vector B with a magnitude represented by small b. Now if I want to talk about the triangle law of vector addition, triangle law of vector addition says that when you join two vectors such that the head of one vector joins to the tail of the other. So let's say that this is a vector A, right? You have to try and connect the two vectors in such a way that the head of one vector joins to the tail of the other vector. Okay, then the third side of this triangle will give me the resultant vector, but it has to be taken in opposite order. Opposite order means that I have to join the tail to the tail and the head to the head. So this side you can, like, this is vector A, this is vector B, and then this one gives you the resultant vector A plus B vector, which generally we represent as R vector. It's very easy to understand provided you look at it carefully. Now over here, if I keep it in mind that A and B are making an angle theta with one another, right? And generally the resultant vector makes an angle, we generally denote it by alpha, that the vector that the resultant makes with the A vector. Okay, then from here, if I want to write down the magnitude of this resultant vector, the magnitude of this resultant vector r would be given by root of the magnitude of A vector, which is A square, plus the magnitude of B vector, which is B square, plus 2AB cos theta, where theta is the angle that the vector A and B make with one another. Right? So you should be able to find out this magnitude. Also, you should be able to find out the direction of this resultant vector. The direction of this resultant vector, if I want to find out, if I represent it as alpha, as you can see, then my tan alpha would be equal to, it would simply be equal to B sine theta upon A plus B cos theta. B sine theta upon a plus b cos theta. Now the idea over here is that yes, you can derive all this, right? But I think that if you're preparing for NEET, then you should not waste your time deriving it. Focus on the result. If you want to derive it, then the idea is easy. You drop a perpendicular from this point where your resultant and beam meet, and then you use Pythagoras theorem, write some sines, write some cosines, and you will get the idea. But for your NEET point of view, it's not required to derive it. Focus on the result, that's more important. Now let us talk about the resolution of vectors. First, let us understand what is the meaning of resolution of a vector. Resolution of a vector simply means that we are going to split a single vector into two directions. So when you have a vector which is pointing in a random direction, let's say I have a vector A which is pointing in a random direction, and I want to resolve this. What does resolution mean? Resolution means that we are going to split up a vector into two directions. So it is the splitting of a vector into two directions. Generally, these two directions are x and y, the horizontal direction and the vertical direction. Now, in order to split any vector, you have to assume that that vector is the hypotenuse of a right angle triangle, and then just complete your triangle. So let's say that this is a triangle PQR, and it is making an angle theta with the horizontal. Then for this particular triangle, I can write sine theta. Sine theta here would be given by QR by PR. So from here, I can say PR is nothing but A. So A sine theta will be equal to QR. Right? It's very straightforward. Similarly, if I write cos theta here, cos theta would be given by PQ by PR. Similarly, PR is again A. So A cos theta is going to be equal to PQ. So I have split my single vector PR into two components. This A vector has been split up into two components, that is AX and AY. X is the horizontal component, Y is the vertical component. So this PQ is representing nothing but the X component, and QR is representing nothing but the Y component. So this vector A can be written as, the X component here is nothing but A cos theta. So it is A cos theta I cap, and it is A sin theta j cap. Now further over here, if you even want to find out the tan theta, like the angle, if you want to relate, then tan theta here can be written as AY by AX. Right, so it is the vertical component by the horizontal component. That's how you resolve two vectors. That is what is called as the resolution of two vectors. Now, since we are talking about NEET specifically over here, therefore we can have a few formulae which are mostly applicable for the NEET students only. So these are related, like these are helping you understand how alpha, beta and gamma are connected. So for example, if I talk about the cosine rule, okay, cos square alpha plus cos square beta plus cos square gamma. The sum of the three angles that the vector makes with the three axes is what adds up to give you 1. So cos square alpha plus cos square beta plus cos square gamma would be equal to 1. On the other hand, if I take the sign of these, okay, so if I take sine square alpha plus sine square beta plus sine square gamma, then these would add up to give you 2. So these are two formulae that are generally used for your NEET exam. So this is, again, if you want to derive, you can derive these, but you can directly use these as well. So these will help you keep or solve the NEET questions specifically. Since we know everything about the vectors now, therefore let us try to solve one of the PYQs here that's related to vectors. It says that if the magnitude of the sum of two vectors is equal to the magnitude of the difference of the two vectors, the angle between these two vectors is. So let's say that we have a vector P and we have a vector Q. If I add these two, then their magnitude has to be equal to the magnitude of the difference of the two vectors. The idea here is going to be very basic. We will simply apply the formula that we learned in the triangle law of vector addition. The magnitude of P plus Q vector would be equal to P square plus Q square plus 2PQ cos theta. And this is directly by using the formula. I have not done any other calculation here. I am just applying the formula. So this is 2PQ cos theta. And now this one further has to be equal to P square plus Q square minus 2PQ cos theta. That's the magnitude. If we replace Q with negative Q, that is what I would get. The angle between P and Q will not change irrespective of the fact whether I'm using theta or if I'm adding them or if I'm subtracting, the angle between the two vectors cannot change. Now from here you can see that we can cancel out the P square Q square on both the sides since it's the same. The 2PQ cos theta and 2PQ cos theta add up, so you get 4PQ cos theta equals to 0. So P and Q are two vectors that you're adding, so obviously they cannot be equal to 0. So this simply implies that your cos theta has to be equal to 0. Cos theta equal to 0 means your theta is equal to pi by 2 or 90 degrees. And hence, these two vectors are inclined to each other at 90 degrees. You could also learn this as a basic thing, that if the magnitude of the sum of two vectors is equal to the magnitude of the difference, then the angle between those two vectors would be equal to 90 degrees. That's all about vectors today. Thank you for watching.